my name is Henry. So we continue with handling point load. Now, as I said earlier, the way the software define the spans, right? The spans are usually supported by either is supported by a column. The ends of the span of the beam span is either supported by a column, or it is supported by a primary support, or it is supported by or it's none. That means free. You can see it's either it's a column support, a primary support, or it's none. Now, looking at the scenario that we have, okay, then this particular beam, you can see the start support type is a primary beam support. That means that it's being carried by another beam, okay. And then you can see that the end support type is a column support. Usually the software will always orient the beams. The start point is at the, like for a vertical beam span, for instance, the start point is at the top and the end point is at the bottom. For a horizontal beam span, the start point is at the left and the end point is at the right. Okay, so that is the way it sorts out the support position of the beam. So now what happens is this: by the time you click load analyze design, if you click load, for instance, automatically when you go over to design and you click load, automatically the software will load the structure, put into account it will be able to dictate the point load and load the structure right away accordingly. And of course, if you click analyze, it will analyze in that order, and you click design, it designs the structure in that order. Now, for instance, if you click on the span that we have, okay, and then you go over to loading. Now you can also see the way the loading is organized. We have the beam span UDL collection, which basically tracks the load from beam span and at the same time the load from wall, okay. And then also you can include self weight of the beam, or you can exclude it, right? Then each individual beam span you can actually consider whether you want to, but some of these settings are done automatically at the default, okay, so you don't even need to waste time. But individually in the beam span, you can actually include the self weight of the beam, like in the case of a raft beam that you want to exclude the self weight of the beam. You can also include the wall loading, or you can exclude the wall loading. Just turn this into false and it will exclude it. And then of course at this panel end collection actually details the loading that comes from panels, right? And we're able to do an incredible work on the way the panels are loaded to the beam. As you can see, we have the first panel is trapezoidal, which is this panel. The second panel also is trapezoidal, which is this panel, and the third panel is triangular, which is this panel. So it takes care of the loading from panel. You can see them in details and see how the load are also arranged. And then we also have the point load collection. Now you can see in this particular beam span, which is from here to here, we have 2 point load. We have a point load due to which is a beam point load, which is coming from this beam, okay, and we have another point load which is coming from the column, that is the roof column or the first floor column, okay. And so you can see the software is able to seek out the point load in such a very wonderful manner. That's one of the big advancements we did in this particular edition, the fact that you can remove a column at will, right? Later I will also show you how you can insert a column at will, and the software will be able to respect your boundaries and put all those things into consideration, load the beam automatically. It will be able to seek out, as it's doing the loading, it will be able to will go and seek out the point load coming from a beam and the point load coming from a column, and it will be able to load the beam span accordingly and then transfer the load downward to the nearest column along the line. Okay, so as you can see, the load is automatically done. So let's bring back the panels, okay, and then our beam. So automatically the load has been done. If you go back to view and you click on column map, right, now you can see the load at this column is now slightly increased, and you can see the load on this column is also slightly increased. increased. And then again, you see something interesting happening at the column map, because in the column map it was able to show us that there was a column at this point. Remember, as I said earlier, the column map actually shows the column map of the building, irrespective of where the column occurs, whether the column starts at the roof and stop at the first floor, or whether the column stops at the ground floor, wherever the column stops. The column map will always show you the column and their togetherness. What I meant by their togetherness is actually like the column and the way they appear. Okay, because in the column map we actually show you everything the way they are arranged. It will show you the column that starts from the first floor and stop there, and you show you the column that stop at the ground floor. Okay, that is the way the column map actually work. So it's quite a very incredible tool. And again, you can see very interesting thing that is happening in this particular place now, that this column is actually stopping at the first floor, and the same column we have it at the column map, but the column map was able to tell us that this column starts from the top level is actually 6300 and the bottom level is 3150, and that makes quite a lot of difference. Okay, so it's kind of simplify the way the column was showing us the information about the column, their start point, where it started, the top level, and then the bottom level. Okay, so that is the column map. And of course, by the time you detail your beam, if I redetail this beam, first floor beam, and of course you can see the reinforcement has also increased, showing that we had a point load coming at that point. That is basically the way you handle your point load. Okay, now whatever happens, if you want to regenerate back your model, just go back to the modeling and then recreate the beam span, and then you can now append a new column. You can see the column is back. Okay, so you are always in control. At any point you feel confused, or any point probably you feel your drawing is scattered, or you are not in control of the drawing, just go back, go back on the modeling, recreate the beam spans, create new, and then you now go and append the column. But remember, once you recreate the beam spans, always recreate your beam and then append column, and the whole column will come back the way they were supposed to be. Okay, so that is basically the way you manipulate your point load. As I said before, it's very simple. All you need to do is just click on the column and delete, and the software deletes the column. And then if you check the beam span, it should have adjusted the span for that particular area where you remove the column. But if for any reason the span was not adjusted the way you wanted it to be adjusted, all you need to do is go to the start point and change the start point, or you go to the end point and change the end point. Once you do that, the software will always put that into consideration. And remember that if, like this particular beam that's supposed to be transferring a point load, make sure it is a primary beam support. And once you do that, everything is okay. Okay, so that is the way you handle your point loads. Thank you for now.